Hey, what's up, students? Let's talk about simplifying before solving. So sometimes you're going to get problems that look a little not as pretty, but they're really not that big of a deal. You can just make them look nice really quick like. So if you have a problem that has a whole lot of decimals, here's what you do. You find the smallest decimal place, tens, hundredths, and then you just take them all times 100, okay? Or you would slide the decimal over twice. So you could rewrite this as, let's see, that'd be 310x plus 680 equals 534. Okay, there we go. But decimal, in my opinion, decimals aren't that big of a deal. So scaling up to remove the decimals, cool. But I mean, I can do math with those. So what's the big deal? Fractions, on the other hand, I think we've done this before. Fractions, you definitely want to make these things look pretty because they're fractions, man. They're disgusting. They're gross. Subtract a half, divide. Scale them up. So how do you do that? Find the lowest common denominator. So we got a 4, a 2, and an 8. I think they're all going to have an 8 in common. So then you go through and you take u times 8, take u times 8, and take u times 8. Okay, mental math. 5/8 times 8 is just going to be a 5. Half of 8 is a 4. You're still positive. 3/4 of an 8 is going to be a 6x. Look how pretty that is. That looks a little bit better. Okay. Now, this one's actually really easy. Really, really large numbers, if you just get tired of writing all of the numbers over, watch this. It's just the reverse of this. Okay, if you move the decimal to the right, guess what you can do? You can move the decimal to the left. So watch this. Goodbye, goodbye, goodbye. Do they all still have another 0? Yes, they do. Goodbye, goodbye, goodbye. Stop! Okay, there is one more 0, but this don't got one and this don't got one. So I must stop there. 12 minus a 5x is going to equal 370. There we go. So that looks a little bit better. Just it's less stuff to write. Okay. So that's how you can make equations with large numbers, equations with fractions, and equations with decimals look a little bit more pretty. Make pretty. Okay. A little bit prettier to solve. The one last thing I want to talk about is a little shortcut here that will help you with some of the story problems. I actually skipped this in the notes. This is kind of similar to problem number 2 from the notes. So this is kind of similar to problem number 2 from the notes, which I didn't do. Problem 2, and I'm not even sure what page it's on. It's probably after problem number 1, so probably page 103. Okay. So here's a shortcut to comparing prices. Okay, we're comparing prices. Why do we compare prices? Because it's very similar to setting two equations equal to each other to figure out when they're equal. So let's say we got a plan 1 and a plan 2. Plan 1 is you pay $100 up front and then it's $10 per day. So it's some type of club, it's some type of, I don't know, whatever you want to make it up. Okay. Plan number 2 is just a $500 flat fee. It's a one-time $500 fee with no extra charges. So these are the fees. These are what you pay up front, and then this would be the rate per day. Look for the word per. That's kind of the big dead giveaway when you see a rate. Okay. So when are these two mathematical situations going to be equal to each other? When is it going to be the same price? Plan 1, plan 2. So if you want to physically figure out when they're equal, here's what you do. You actually just physically set their equations equal to each other. Okay? So when are they equal? This will help you figure out when it's equal. You physically set them equal to each other, and then you do math. So that's in this case, it's a two-step equation because this is a one-time fee and there is no rate with it. Okay? So I'm going to show you a shortcut here. The quickest way to find the answer to these is you take the difference in the fee divided by the difference in their rates. Okay, so if you write that down, I'll show you an example. You might have space somewhere in your notes. I'm sorry, I wish I would have found more room. But if you can find a chance to write this example down, go for it. Okay, so we're going to start over, kind of do the same thing here. We're going to be comparing some prices. So let's say plan A starts off with $60 and it's $3 per month. Whatever plan, or cell phone plan, utilities plan, a club plan, whatever you name it. Okay, there's lots of different flavors of these things. Plan B starts at $50, but it's $5 per month. So we have a plan that's more expensive to start, but less expensive over time. Less expensive to start, but more expensive as the months go by. All right. So when are they the same? That's the question, because that will kind of help you decide which plan you're going to use. If you're going to do one of these plans for 10 months, 20 months, several years, or just for a few months, that will kind of maybe influence your decision. Well, it should influence your decision because you're a good consumer, right? So here's what you would set up. So you would physically set them equal to each other. You'd 1-step, 2-step, and then 3-step, okay? But here's the shortcut, okay? Here's the shortcut, students. Here's what I do. I take the difference in the fee and I divide by the difference in the rate. So Plan A is $10 more expensive. So Plan A has a $10 head start, okay? But the difference in the rates is 2, okay? Plan B is catching up by $2 each month. So when will a $10 head start get eaten up by a $2 per month difference? 10 divided by 2 is 5. At month 5, students, at month 5, these plans will be equal. So that's where you make your decision. So they're equal at 5 months. So are you going to use this for a long time or not as much of a long time? So if you're going to be using this plan for over 5 months, I would recommend Plan A. Why? Because it costs less per month. Yes, it's more expensive to start, but $3 is not going to grow as fast as $5. Okay? If you're using this plan for less than 5 months, I would recommend Plan B because it's cheaper to start. Okay, it's very much cheaper to start. You could make a table and go 1 month at a time. You can set the equations equal to each other and do math, or you can use this amazing new shortcut. If you remember all the way from early on in chapter 1, I did something kind of like this. We were talking about like if it's open or closed or true or false or something like that. I can't remember. No, we were talking about open sentence, true or false. We were talking about that. And then I did a little shortcut like this. Okay, what I did was I did the difference in the numbers divided by the difference in the variables. Boom, instant calculation. All right. So that's how you compare prices. And then once you figure out that magic number, that's where they're the same. Because if I were to draw a quick sketch, here's what we got. Let's say we start at 50, we start at 60. Okay, one starts at 50 and it's increasing by $5 a month. One starting at 60 and it's increasing by $3 per month. Okay, so that's not supposed to be supposed to increase a little bit more, but they're going to crisscross. This line is growing faster. This one's growing a little bit slower because it's only 3 per month. So that magic number right there is 5 months. So less than 5 months, we have Plan B right here. We got Plan A. So less than 5 months, you can see the lines below, so it's cheaper. After 5 months, Plan A is cheaper. All right, so there's a physical picture of what's going on there. All right, this video is going on for a billion years. I wanted to make sure you saw that. Otherwise, I'll make sure I cover this in class at least once. Otherwise, that's it. We'll see you in class. Goodbye.